So now it's time for our king. So our king, as we already discussed, has two moves. This one is one in every direction. So we just calculate, it's a simple check. Here we have our pawns, and here we check if the move is legal, because the initial move for the pawn can be either 1 or 2 fields, but only if it's the very start position. And we check how many rows the figure moves. If it's more than 2, or it's not the starting position, we return this move is illegal, or the other case is a standard move. But our pawns can also do attacks, and as we talked, the columns must be different, right? And again, it cannot move to, it cannot attack empty spaces. Yeah, so that's why it is illegal, or cannot attack own figures. And if it's opponent's figure, we return attack. So now we can go back to our king. Here we have our more complex case for a king, which is castling. So castling is always moving king by 2 fields. Yeah, so that's why, and only in a one axis, which is, I mean, on the same row. We calculate start and stop, and here we check if the whole path is free. Yeah, so there must not be any other figures in king's way. Next, we do a copy of our board, and this is for the purpose of this function. This function is not defined yet, but what happens here? This move is legal only if there is if the opponent is not attacking any fields that king would have to pass doing this move. If any of the fields would be attacked by the opponents, we user cannot make this move. Here we revert our changes, and if the move is okay, then we can move we can return a standard move, or return that movement is illegal. So we need to define this function, and this function is very simple. We just check if it's a turn of player 1. If it's so, we have to search for the different king, let's say. Yeah, and we need to check if the king is in a check. And this is very simple function as well. We provide a figure of a king, either capital or small letter. We need to find king's position, and then we need to simulate its movement. And we also use this collision system. That's why we had to use this copy of our board previously to avoid this permanent overwriting. But as you can see, it is regular move. We check if the move is valid. We check collisions. So we simulate going this king step by step. And we need also a function to find our king. And because it's an internal function, you can define this as protected at the end of our class. And here in our game board, we search for this king. It's case sensitive, and this is another good example of exception. We should think about exceptions as a real exceptions, not about some errors. In the previous code, you could see that we return some illegal or some movement unknown, because this is something that may happen. But if there is no king on a board, there is an exception, because this is a very, very unusual situation. That's why showing an exception here is a good example how to show those exceptions. Yeah, so we are looking for a king, and we calculate its position, row and column, because that's how we operate in other places, and then we have to revert it back to one-dimensional array for our calculations. But to keep the row column coordinates consistent, we return this as it is. One missing thing is that property. It is not defined anywhere, so we need to add it to our class. It's something that only our class can modify. We can also do small refactoring here. This will help us later. We return our own object, so it will allow us to do chaining. Okay, so more or less our collision detection system is done. So we can go back to our move function and handle this new return values. And now it's time to take care of this movement, because right now, regardless of this value, we always do this movement. So to make any movement, we need to check if that makes sense. Any other movements like unknown, illegal, friendly fire, roadblocks do not move a figure at all. Okay, but that's of course not enough, so let me paste another snippet. As you could see previously, we did this copy of our game board. This is temporary copy, and this is for purpose of this very function. What this check does is when we try to move our king cannot be under attack at any time. So even if our movement is legal from the figure point of view, I mean, it attacks opponents, or it occupies the empty space, no friendly fire, no roadblocks, and so on. This is okay, but it cannot expose our own king to attack of our opponents. So that's why we do this temporary check. Yeah, we do a copy, then we set our figure that we would like to move to the new location. We release a location of the which was occupied so far, and then we check if that movement will not expose our king to attack. If so, then this king would be in check, and that move would be illegal. Yeah, and here we do this copy back to the original board. And if our king is not under attack, we can check if castling is what user wanted to do, and we set this value here, right? We set this castling true. This is for our king, only if it's valid. So that's what the user wanted to do. So if that's what user wanted to do, we do this castling. We don't have this function yet. So we will move figures, and we will return either true or false. Yeah, so if the if the casting was done correctly, if the figure that moves was a rock, we need to figure out which of them it was, either on the left or on the right side. And then we set false value for this figure. The same is for king. If the king was moved, we set false. And this is because castling is valid only if none of those figures was already moved. We don't have this eraser yet, so let's define them. So there will be two protected variables, and we have our reset function. So let's track it here, and that's how it looks. It's a rock, king, rock. So all are correct. I mean, we're not moved yet. If any of them was moved, we set false. So this figure cannot be used in the future for castling. So the only missing part is this function, so let's define it. We also a protected function just for the internal use. So we accept move, we return true or false side on the castling, right? Because we can move either right or left. We check as already defined array, because king is in the middle, so it always has to be true. And the figure either on the left or on the right, depends on the castling, has to be true as well. If any of those values is not true, we return false, castling failed. That's for the player number 1, and for the player number 2 we do the same. We could make it as a one two-dimensional array and use some indexes, but this is also absolutely fine solution. So if it's this value for the player 1 and this value is true, we go here. If it's a player number 1, we set those values to false, because casting can be done only once. Those are indexes for figures to move. We take our game board, and under this side we release an empty space, and we move our rock to its new location. King was moved previously, that's why we move only rock. And the same is here, but this is for the player 2. So we did quite a lot of work. Only missing part is this part for the end user. So let me paste a snippet here, like this. This can be used for debugging, but we don't need it right now. So we make a move. If the move was correct, was recognized as a move, we jump to this if statement. If it wasn't, we display to the end user a message that we couldn't recognize this as a movement. If the movement itself was correct along the axis, then we can check what happened next. If the king was in check, we display corresponding messages based on the value that we returned. If the movement wasn't valid at all, we just display a wrong move message. So let's see how it works. Okay, so let's see. Let's try to move from C1 to B2. Okay, we didn't define king in check. Okay, yeah, indeed. King in check and castling. Those two values were not defined. This is 0 by default. Okay, so one more time, C1 to C2. Okay, that makes sense. C1 to B2, friendly fire, makes sense. Okay, so something is wrong with this check, because our king is not in check, but the opponent's king would be under attack. We'll check it in a second. So okay, so the issue is that this game is not complete, so something like double moves on our side doesn't make sense, like B2 to B3, C1 to A3, and A3 to E7, right? So we can attack the opponent's king. The thing is that every move changes whose turn it is. So it happened that I did enough moves that our king was under attack. We will fix it in the future, but for now we just prepared validation of the movements itself, and we detect collisions. So that's it for this episode. Thanks for watching, and see you next time.